Hello friends, welcome to Learner's Planet. Friends, this is Geometry Workshop. In this session, we'll be discussing triangles, circles, quadrilaterals, their properties and problems based on them. In the previous session, we have discussed the basic properties of triangles. We discussed the relationship among area, semi-perimeter. We discussed the various terminologies related to triangles, maybe circumcenter, incenter, orthocenter, medians and all that, right? So I hope you might have revised that particular session before you are coming for this session. So let's begin this one. Have your paper and pen with you. Just note down the important points, and if I discuss any problem, just try to solve the problem right with me. Okay, so let's begin. Now let's discuss this question. A parallelogram with the perimeter of 44 cm is divided by the diagonals into 4 triangles. The difference between the perimeter of two adjacent triangles is 6 cm. Find the length of sides of the parallelogram. Now I suppose this is x and this is y, right? So perimeter is 44, that means x plus y must be 22. Okay. Now the difference between the perimeter of two adjacent triangle is 6 cm. Find the lengths of, okay. Now this is what, suppose 2d1, then this will be d1. This is suppose 2d2, that means this will be d2. So this triangle, the perimeter will be x plus d1 plus d2. Similarly, perimeter of this triangle will be y plus d2 plus d1. That means d1 and d2 is precisely same. That means actually the 6 cm is nothing but the difference between x and y, right? So now we can find out the length. X will be 22 plus 6, that is 28 by 2, 14, and y must be 8, as simple as that. Okay. Now we have this problem. In an isosceles triangle, length of the base is 24. So this must be 12, this must be 12, and since this is an isosceles triangle, this must be altitude. And that of lateral side is 15 cm. So this is 15, this is 15. Find the radii of inscribed and circumscribed circle. Now friends, instead of doing lot many calculations, what we can do, in case of radius of inscribed and circumscribed circle, we can directly use the formula, right? Area of any triangle is given by ABC, that is product of sides, by 4 times radius of circumcircle, and the same is given by PR, where P is the perimeter and R is the radii of inscribed circle, right? So that will be very easy for us to solve the problem, right? In minute we can solve, right? Now here this is 15, this is 12, that is 3 into 4, that is 3 into 5, that means this must be 3 into 3, right? So 9, 12 and 15, these are Pythagorean triplets. So this is 9, right? Now we can find out the area of this triangle easily. So that's half base into altitude, right? Now this is the area. Product of the side is what? 15 into 15 by into 24, right? By 4r, right? So if we solve this, we'll be getting the value of r, that is radius of circle circumscribed. So r is 12.5. Similarly, using these two, half of 24 into 9 is p into r. P is what? 15 plus 15, that is 30, plus 24, 54 by 2, right? That is semi-perimeter, and that is radius of incircle. So that's 4, right? So these two are important formulae when we discuss the cases of circle and triangle, whether it's inscribed or circumscribed, right? So these formulae give us the important relationship that can be useful. Okay. Now this one, the angles of a triangle are related as 2:3:7. The length of the smallest side is 4. Find the radius of the circle circumscribed about the triangle. Now this is 2 plus 3, 5 and 7, 12. That means 180 by 12, 15 part. So the angles will be 30, 15 into 2, 15 into 3, 45 and 15 into 6, 705, right? This suppose angle A, B and C. Right. Now what we have to find out the radius of circle circumscribed about the triangle. Now the smallest side is 4, right? And the smallest side is which? The side that is opposite to the smallest angle, right? So that means suppose this is sine, I just draw the diagram. This is A, then this is 30 degree and this is 4, right? I suppose this side to be B and this side to be C. Now what can be done? What is the area of this triangle? That is half BC sine 30 degree. Sine 30 degree is what? 1 by 2, right? And that is actually area is given by ABC by 4R that we have discussed in the previous question, right? Here A is what? 4, right? So 4 to 4 is cancelled. BC to BC is cancelled. So R is equal to 1 upon 4. Sorry, 1 upon R is 1 upon 4. That means R is 4. That means radius of the circle circumscribed will be 4 only. Okay. So just by knowing the formula that S is equal to ABC by 4R and S is equal to half BC sine A. Both of them are area of this triangle, right? So that this problem can be solved very easily. I hope you are clear. Now let's see this problem. Once again we are having a problem based on the combination of circle and triangle. A circle of radius r is inscribed in an isosceles triangle. The altitude drawn to the base is divided by the circle in the ratio 1:2. Find the area of the triangle. Now friends, what is happening over here? Radius is r, right? Now this point is divides this line into 1:2 ratio, right? And this is what? 2r, right? 2r, because that is diameter. And this point is dividing this complete line into 1:2 ratio. That means this we can say from this to this it is 2/3 of height. This is altitude obviously. So this is from this to this. This is 2/3 of height, and obviously this to this it is 1/3 of height, right? This portion and these three portions are equal to each other. So R will be 1/3 of height. Radius of this circle will be 1/3 of height. Okay. So that is R. Now similarly capital R, that is from this point to this point, that will be actually 2R. Right? Or that is actually circumradius you can say. So this will also be circumradius. So that will also be 2R. Okay. So that's I just take this as O, and this is R, this is 2R, and this is suppose P, right? So they will form a right angle triangle. So this is R square plus P square is equal to this, I'm sorry, this is 2R, 4R square, right? So P square is equal to 3R square, or we can say P is equal to root 3R. Now for an isosceles triangle, this is half of the length, because altitude and median both of them are same. So the complete length will be 2 root 3R. So that is base. Altitude will be what? 3R, R plus R plus R. So this is 3R. So that is base altitude divided by 2, right? So that's 3 root 3 R square. That will be the area of this triangle. Okay? You got the difference? This is in radius and this is circumradius. Should be clear about it. Okay? Now we have this problem. A circle of radius 13 centimeter touches two adjacent sides of a square, the length of whose side is 18 centimeter. Into what two segments does the circle divide each of the other two sides of the square? So I draw the diagram. Now this is the diagram. Now friends, to solve this problem, we'll be taking the help of coordinate geometry. I suppose this to be origin, right? I'm taking this complete side to be positive side, so do not get confused. You can reverse the diagram as well. So this is 0, 0. Coordinates of this point will be what? This is the height, that is 13, and this is y-axis. So the coordinates of this point will be 0, 13, and here the coordinates of this point will be 13, 0. Coordinates of this point will be 13 and 13. Right? Now equation of this circle will be what? Suppose any point on this circle is x, y, any point, right? So x minus 13 whole square plus y minus 13 whole square is 13 square. Obviously, we just have used distance formula. X minus 13 whole square plus y minus 13 whole square is actually 13. That is the radius of this circle, right? Now we have to find out the coordinates of this point. Now this point is actually what? The height of this square or side of this square is actually 18. That means y coordinate is 18, but we don't know the x coordinate. So I write x coordinate as h and y coordinate is 18. Now this point h18, that is also lying on this circle, and we are having this equation of circle. That means h18 should satisfy this equation, right? So I put h and 18 over here in the place of x and y. So this is h minus 13 whole square plus 18 minus 13, that is 5 square, that means 25, and that is 169. So that is 144. So h minus 13 is 12. Or minus 12, right? H minus 13 whole square is 12 square. So h minus 13 is either 12 or minus 12. 12 minus 12. Now h cannot be 25 because this maximum, this length is 18, right? So h will be minus 13, this 12, minus 12 plus 13. So h will be 1. So coordinates of this point will be 1 and 18. Okay. So this point is what? 1. That means this point, this length is, the total length is what? 18. So this length is 1. So this length must be 17, right? So into what two segment does the circle divide each of the other two sides? That is 1 and 17. Getting my point? It is very simple if you use coordinate geometry over here, right? So this is a problem based on square and circle, and we have solved it using coordinate geometry. As I've already told you, you must be having the basic knowledge of coordinate geometry, trigonometry, geometry as well. Okay? I hope you are getting my point. The segments are 1 and 17. Now friends, let's try this problem. A circle is inscribed in a right triangle. The point of tangency with the circles divides one of the legs into segments 6 and 10 centimeter in length, reckoning from the vertex of the right angle. Find the area of the triangle. I draw the diagram first of all. So this is the diagram. Now the point of tangency with the circles divides one of the legs into segments 6 and 10, right? This is the vertex. This from here to here 6, and this must be 10 from this point to this point. Okay. Now this is the center of the circle, this and this, right? So this length and this length should be same, then this and this should be same. So all the lengths are 6 because this will form a square. Now I assume this length from this point to this point to be x. Then from this point to this point even it will be x, because two tangents from the same point will be of the same length. Similarly from this point to this point it is 10. That means from this point to this point still it is 10, right? Now this is right angle triangle. We have to find out the area of this triangle. So what we can do, we can find out x, right? We can use Pythagoras theorem. That is x plus 6 whole square plus 16 square is equal to x plus 10 whole square, right? So that is x square plus 36 plus 12x plus 256 is equal to x square plus 20x plus 100. Okay, so 20x minus 12x, 8x is equal to 256 plus 36 minus 100. So 8x is 192, x is equal to 24, right? So now we got this length. Now it's very easy to find out the area, base into altitude. So half base is 16 and altitude is 24 plus 6, that is 30. So that's 240 units, whatever, square centimeter or whatever, but 240 units will be the area of this triangle. Okay, I hope you are getting me. Now let's see this problem. A semicircle is circumscribed on a larger leg of right triangle as a diameter. Find its length if the smaller leg is 30 centimeter and the chord which connects the vertex of the right angle with the point of intersection of the hypotenuse and semicircle is equal to 24 centimeter. Yeah, first of all I draw the diagram for it. Now this is the diagram. Here smaller leg is 30, that means this length is 30, this point is O, this length from the right angle vertex to point of intersection of triangle and circle, this length is 24, right? Now this angle will be 90 degree because OP is diameter, okay? So this will be angle in semicircle, so that is always 90 degree, okay? Now what if this is 90 degree, this angle will also be 90 degree. So 30, 24 and this third one is they will form Pythagorean triplets. So this is 6 into 5, this is 6 into 4, so this must be 6 into 3, that is 18. Okay, this is OQ and I suppose this is R. Now ORP is a right angle triangle and we have discussed it so many times that the other two right angle triangles in this horizontal right angle triangle, all of them are similar to each other, right? That means ORQ is similar to ORP. Okay, now what we have to do? We have to compare the sides, or we have to make the sides in proportion. This is suppose R, this is suppose R, so this is actually 2R. Now how do we make the comparison? First of all, in the small triangle, the side opposite to 90 degree is 30. In this case, the side opposite to 90 degree is what? 18 plus, suppose this is Y. Then the side opposite to the common angle. So that's common angle is this. So in this case, the side opposite to common angle is 24. And for the bigger triangle, it is 2R. So 30, 24, the third side is 18. Here 18 plus Y, 2R, and the third side is 30, right? So we can take these two, 6 4s are 6 3s are 3, 10, 2, 5. That means R is 20 centimeter. Now you got R, you get everything, right? Now what you want? The length of the semicircle, that will be what? Diameter, this diameter plus half circumference. So diameter is what? 2R, that is 20 into 2, 40 plus this that is half circumference, that is pi R, so that's 20 pi. Okay, so if you are asked only this length, then it will be 20 pi and this complete length, that means the perimeter of the semicircle, then it will be 40 plus 20 pi, right? Here we are asked about this length only, so that's 20 pi, right? And if you are asked about length of hypotenuse, then you can calculate Y, where 30 upon 18 plus Y is 1 up this whatever 18 by 30, so from that Y can be calculated and you can calculate the length of hypotenuse, right? So once the concept of similarity is used, everything is very easy, right? I hope you are clear. So many times we have used the concept of similarity in a right angle triangle. Now I am sure you must be comfortable with that, how to take sides in proportion, how to apply the similarity axiom and all that. Okay. Now let's see this question. A circle is inscribed in a right triangle whose perimeter is equal to 36 centimeter. The point of tangency with the circle divides the hypotenuse in the ratio 2:3. Find the length of the smallest side of the triangle. Now friends, for this, if I tell you no paperwork is required, directly you can solve the problem. The very important and good thing with us is the perimeter of this right angle, right? Now what? This is P, B and H, right? P plus B plus H is 36, right? That and PBH must be in Pythagorean triplets. The simplest Pythagorean triplets with us is 3, 4, 5. Let's check. So it's the sum is 12 and we are getting the sum is 36. So multiple of 3, 4, 5 will also be in Pythagorean triplets. So if I take the 3 times of each, that is 9, 12 and 15. Right? This is 36 and these three are the lengths of this right angle triangle, right? If you go by this method, you don't have to use any other data or whatever is given. No paperwork is required at all, right? You need to find the smallest side, that will be 9, right? Now that is the shortcut, or we can say common sense, or you can say smart way. Now how do we do this problem by regular method, that also we should discuss. Now let's try. The point of tangency with the circle divides the hypotenuse in the ratio 2:3. So this must be 2x and this must be 3x. So if it is 2x, it will be 2x. If this is 3x, this will be 3x, right? And this I assume to be r, and simultaneously this will also be r, right? Now what I know, sum of all these is 36. Okay, so that's 2x plus 2x plus 3x plus 3x. So the 2 and 2 4 and 3 7 and 3 10x. 10x plus 2r is 36, right? And apart from that, we can use Pythagoras theorem. So 2x plus r whole square plus 3x plus r whole square is equal to 3 and 2 5, that means 25x square, right? So by solving these two, you'll be getting the value of x and r both as well, right? Obviously it will be a bit lengthy, so the method that I discussed earlier is the best. You can go directly by options as well. You can choose the Pythagorean triplets where the sum is 36 centimeter. Okay. Now let's see this problem. Given a right angle triangle ABC, a circle is constructed on its altitude CK S diameter, which cuts the legs CA and CB at M and N. CM is 12, CN is 18. Find CA and CB. Now this is 90-degree angle. Okay. This is center. I drop a perpendicular over here, right? Now this length must be half of 18, because if I drop a perpendicular from the center to the chord, it bisects the chord. So this is 9. This complete length is 12, so this must be 16. So by this we can calculate r, right? So r square will be 81 plus 36. So r is equal to 3 root 30. Now this complete length is 2r, right? Now what I do, I match this m and k, and from here k and n, right? Now what? This is CK is diameter, so this will be 90 degree, and further CK is diameter, so this angle will be 90 degree. This or this, whatever, right? Now what? As I've already discussed you various times in the sessions of geometry and workshops of geometry, if there is a right angle triangle, right? This is a right angle triangle, right? Now in that case, what happens? The two right angle triangle into this triangle and the original triangle, all of them are similar to each other, right? So that property I'll be using to find out the lengths which have been asked. Okay. So first of all, I take triangle CKB and triangle CKN, right? CKB, original triangle, CKN is the triangle inside this. So CKN and CKB, both of them will be similar to each other. So I can equate the sides. Let's do that. Now in triangle CKN, the side opposite to 90 degree is what? CK, that's 2R. In this bigger triangle, the side opposite to 90 degree is BC, is equal to the side opposite to common angle in the bigger one is BK, and the side opposite to common angle in this triangle is KN, and KN is actually 12. The third side, that is, this is, so it's 2R KN. Here I have written wrong, though we don't require this. So this is 2R, this is K, and the third side is CN by the third side of this bigger triangle is CK, that is 2R, right? So CN is nothing but 18, right? Now from this and this we can calculate BC, right? 2R is what? 6, this 2R into 2R, 4R square. So 4 into R square will be what? 13 into 9 is equal to 18 BC. Okay, 4R square is equal to 18 BC. 4R square is 13 into 9 is equal to 18 BC. So BC is 26. Okay. Similarly, this triangle this CMK will be similar to triangle AKC. Same way, we are going to compare the sides. So we'll be getting 2R upon AC is equal to 12 upon 2R. So for the 4R square is equal to 12 into AC. 4 into R square will be 13 into 9. That's 12 into AC. So AC will be 39. Okay, so we got 26 and 39 as BC and AC. I hope you are clear. Simply by using the concept of similar triangles, we have done this problem once again. Okay. Friends, in the next session, we'll be discussing more problems based on geometry. I hope you might have enjoyed this session. So let's meet in the next session once again. Bye-bye.